All right, so I think we're on assignment 9. And was everybody able to graph the absolute value stuff pretty easily? Or is there any questions on that? We could do another one, so you can see, so I could see, so you can see if you understand it. Okay, number 9. All right, so let's come up with a function. I don't know, something simple. We'll do an absolute value, and we'll put a negative in the front. All right. So real quick, what's the first step to graphing? Now, it's
We
not.
can't see it.
Oh, thank you. Appreciate that. And I always ask the same question. And wait 1 second, it's coming right now. So I always ask the same question. What's the first step? And it's not really the first step. It's actually my suggestion for a first step. And looks like looks like you guys still can't see the graph. Can you see it? No.
We can see it.
Oh, you see it? Okay.
Yeah, we can.
All right. So I have a function here, -2 times the absolute value of x minus 3 minus 4. So what's the first step that I recommend, right? Is my recommendation. What do you guys think?
Find the vertex.
Find the vertex. And you should know by now that it'll look like this, right? It might be upside down, it might be skinny, it might be wide, it might be somewhere not at 0, 0, but so let's find the vertex. Find vertex. All right. And what do you recommend to do to find the vertex? What do you guys think? What do you recommend is your what do you recommend? I recommend you you want to find which find x that cancels -3, right? And what x cancels -3? Come on, guys, you got to participate with me here.
3.
3. All right, even though it's pretty easy, right? So 3. So x equals 3. So we got to plug it in. We got to plug in 3. So we're going to do -2. Now, you know what's going to happen because that's why you picked 3, right? -3 minus 4. This would be -2 times 0. So it'll be 0. So that means the y is -4. So that's our vertex. 3 comma -4. All right. And next, on absolute value, are the little steps the same height as all of them, or do they change heights?
Absolute value is the same. I can't speak
Yeah.
English.
It's okay. Quadratics. There we go. Yeah, I almost said quadrilaterals, right? I meant quadratics. Yeah, you're right. So absolute value is the same. So all you gotta do is find the first one. So it's going to be 3 -4, 3, 1, 2, 3, 1, 2, 3, 4 down here, right? That's vertex. 3 -4 vertex. So all we need is one of the first steps. Now, with time, you're going to be able to see the number, and you'll know what the step is. Anybody know what the size of the first step is?
Mister, can you go up a little?
Yeah. It looks like it looks kind of light on there, right? And that should have made it lower. Now, just for the graphing of this case, just for this problem, let's change everything to plus 4, because then the graph will be up. So put plus, 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 and our graph will be up here instead. So we'll erase that one. I want, because the graph's going to be going down, and it's already lower, so it's going to be hard to graph. All right. So anybody know what the height of the first slope step is?
2.
2. And what kind of 2?
Negative 2.
-2. It's exactly -2. Now, let's suppose that you didn't know that, right? You didn't know it was -2. Well, if you made a table, all you got to do is one problem. Well, let me get my pen back. Okay. So if you made a table, and then the vertex is here at 3, 4. So all you got to do is plug in the next number of 3, which could be 4, or you can plug the next number, which is 2. So which one do you want to plug in, 2 or 4? It doesn't matter which one, but which one do you want to plug in? Now look at the problem. Do you want to subtract? Do you want to subtract 3 from 4, or you want to subtract it from 2? And I think I heard him say, yeah, you want to subtract. Okay, let's try 2. All right, and we could do 4. It doesn't really matter. So it's -2 times the absolute value, and then we're going to plug in. By the way, I would have picked 4, but it's all good because 4 minus 3 is 1. Right? Make sense? So we plugged in 2 here. All right, and there's -2. And what's 2 minus 3? -1. Does that make sense? And is this -1 times -2, or is it negative? Does this become positive right here? Make sense? So the absolute value means how far is it from 0? So this is -2 plus 4, which is 2. So this answer is 2. And which answer is also 2? Okay. So how far did it go? Did it go up or down from 4 to 2? It went down 2. So it went down 2 over 1. That's my first step, right? So don't all the steps become the same size? There we go. And then the opposite way, and then opposite way. Okay, so this is pretty much as complicated as you're gonna get on graphing. So I'll just throw a negative in here. By the way, here is if you don't want to do math, this will tell you the size of the steps. Step sizes. Step heights. Does that make sense? So if you don't want to do this, but you understand why it works, then you can just start using your steps right there. Okay. All right. So I'm going to give you one to try by yourselves, and then I'll wait for you. Okay. And then we'll do the other one. And ask me questions, guys. I really enjoy when you ask questions. There is no question that is wrong here. Okay?
Can you go back up?
Yeah, of course. Yeah, let me bring that up. Okay. So if you want to be like a pro at this, the number in front of the absolute value is the step's height. And by the way, what if there was no number there? What number would really magically be there? So for example, if I had x minus 3 plus 4, what number is out here? So what number times anything doesn't change the value of it?
Is it 0?
Close, very close. 0 times anything will actually make it 0, right? So 0 times 5 is 0. So what times 5 is 5? 1. There we go. So the magic number is 1. If there is no number out here, the steps are 1 foot height. That's the generic absolute value, right? When you don't need it. So every absolute value, the steps are 1, 1, 1, 1, 1. Unless there's a number out here, then they're going to be times that number. Okay. All right. So is this piece super necessary, this extra part right here? No, but in case you forget, then you could just plug in some numbers, All right, try this one, okay? And let me just kind of write it here somewhere. See if you can do this one. Try to make it so that you can still see part of this. All right, I'll write large. All right, g of x is negative 1/2 absolute value x minus 2 absolute value plus 3. Go ahead and graph it. Just give it a try. Oh, by the way, what size are the steps?
+3.
Remember, the size of the steps are in front of the absolute value.
Oh, negative 0.5.
Yeah, so that means the steps, you're going downstairs, and they're half a size, right? They're half a foot. Go ahead and try it, everybody. First is find that vertex, right? The vertex. After a while, you'll be able to find it just by looking at it. Okay, don't shout it out yet. We'll give everybody a little chance to find that. All right, everybody, what is that? What is the vertex?
3.
3 would be the y, right? I like it.
Yes.
And what number will cancel this negative 2?
2, positive 2.
Regular 2, right? So there's your vertex. You could just look at it and say, hey, what number cancels out negative 2? 2. That would be my x. What number is still there? 3. Hey, by the way, what happened to that 1/2? How come it disappeared? If you put a 2 in here, this is going to become 2 minus 2. And what does that become? 0. And what's 0 times negative 1/2? 0. So the number 2 will blow up this whole what? This whole thing will disappear. And what's still there fighting for its life? 3, okay? All right, let me cancel this little mess. All right, guys, so let's just finish graphing this. Oh, what the heck? There we go. So let's graph it. The vertex was 2, 3. So 2, 3, give or take, right? And what are we going to do from there? We're going to go up or we're going to go down, and how much are we going to go down? What do you guys think? Are we going to go up?
We're going to go down by 0.5.
Yeah, we're going to go down by half. Thank you for participating. Appreciate that. So we're going to go down half over 1. Down half over 1. It looks like we can skip. We can go down 1 every 2, right? Instead of, does that make sense? So these are like longer steps if you want, right? Or you can just do the halves. Okay. And then boom. And what about the other side? Same what? Same thing. Just go down half. So you could take little steps or bigger steps. Anyway, you get the idea, okay? So you can write a note here. Steps, the slope things, right, are half.
Wait, I have a question.
Yeah, and over 1. Yes, sir.
So we go down half, like a square, and then we go to the side 2?
No, you always go over 1.
Okay.
Right?
Okay.
But what if you wanted to skip that step? You can go down a full 1 and go over 2. It's sort of like if I gave you 50 cents every day, couldn't I just give you $1 every 2 days? Does that make sense? Couldn't I just go down $1, but every
Yes.
2 days? So these steps are wider, right?
Yes.
They're wider than they are taller, right? Okay, good question. All right. All right, keep on asking those questions, guys. I really appreciate that. It shows you're thinking. Shows you're, not just regurgitating, and but you're curious about certain things. All right. Any questions so far? Now, with time, you'll be able to find the vertex just by looking at it, and then find the steps just by looking at it. Right? These are the what? Steps. Okay. And remember the vertex, this number is the y of the vertex. That's the y, that's the output. And the input is the number that cancels out this -2. Okay. All right, it'll take time.
I'm confused on the part where you're writing steps are half over.
Oh, got it. So the the original steps are up 1 over 1, up 1 over 1. You see my little graph here?
Yeah.
That's a normal absolute value, right? But this one says instead of 1, we're going to go down to half. So instead of 1, we're going to go down half. Let me erase some of this. Watch this. Yeah. Does this work?
Come on. Oh, okay. I think I get it.
Yeah.
I think I was just confused because you were talking about.
Oh, yeah. Right. Exactly. Right. So, yeah, exactly. And I'll even repeat that just for anybody else. So the vertex was here. And instead of going up 1 over 1, I'm actually going to go down half, right? Down half over 1. Okay. And then another half, right? Over what? Over 1. Okay. Now, if you want it to be slick, you can go down a full 1, right? Over 2. Okay. And you don't have to do that. It's just, it's just a way to be a little clever about this, right? And then there's your.
So if we did that on like a test or a quiz, would we get it wrong?
No way.
Okay.
No way. You could, I would just suggest you just stick with what it is, the half, right? But then if you went down a full, it's the same thing, right? Down 1 over 2 is the same as down 1/2 over 1. So what is 1/2 divided by 1? It's still what?
0.5.
It's still the same thing, right? It's the same thing. Okay. Now, so I'm kind of cool. I'm kind of glad that I can zoom in on these little graphs, right? Okay. All right. Keep on asking those questions, guys. And so I'm going to, and this time we're not going to graph it. We're just going to look at it and know what's what. Okay. All right. Here is C for Claudia. X equals 3 absolute value x plus 3 absolute value plus 3. All right, guys. What's the vertex?
-3.
Yep. Exactly. -3, comma what? Comma what?
+3.
+3. Exactly. Okay. And what size are the steps?
+3.
Also 3. 3 over 1 if you want, right? Rise. And then what? Run. Okay. All right. And this time I'm going to give you letters. Okay. All right. A4. All right. Okay. We got, let me just put a different letter, D. A, absolute value, X plus H absolute value plus k. All right, here we go. By the way, these are the letters that mathematicians use. I'm not making these letters up. All right, what's the vertex?
Negative h.
Negative h. Yep. I want to say opposite of h. I'm going to write negative h, but I'm going to read it as opposite of h. You guys like that idea better? Because what if h is negative? Then it'll be opposite, which would be what? And what's the y value?
K.
K. Yep, whatever k is, whatever, it's a placeholder, right? It's just a number. It will be a number. Okay. And what size of the steps?
A.
A. Steps height, all right? Is A over 1, right? So, did you see how we are not doing as much math? Now we're just understanding the math, okay? Little by little. All right, questions before I give you the other one. Now, the reason I did this was because the next thing I have, I'm going to use these letters, okay? No, Colin, we'd have no concave. We'd have a Desmos. I have a, and I'm going to have it ready. Anybody have any questions on this? And it's okay, right? You can have questions as we come along. All right. So the steps of a absolute value are the same, right? Now, which steps are get bigger and bigger on which kind of functions? And I even wrote it here, quadratics. Okay. So what you're gonna do, and don't do this yet, because I want you to take notes on it first, and then I'm gonna let you guys do it, and I'll stay with you until you do it. Okay.
For the Desmos, do we have to like write it down on a piece of paper, or do we just put it in and then we're good?
Yeah, we're just gonna put it in. Okay.
Okay,
Yeah.
cool. Awesome.
I appreciate that. So, and it's gonna be so simple, but I probably spent like an hour making this thing for you, because look at all the formulas I had to use in order to draw these steps. Now, I had this in my brain and I wanted to make it so that you could see. So I spent about an hour making. Now look at this. Look at this quadratic here. What's the size of the first step? How tall? Let me bring the graph a little down. What's the height of the first step? It went from 0 to 1. And what's the height of the next step? I even made them in color. See the green one? It's 3. And then the height of the third step is what?
5.
5. I even made 4 steps. And then what happened is I did it, I actually didn't save it, and I had to redo the whole thing. I was so bummed out because I had finished this whole thing, and then I pressed the back button, and it didn't save it. So I had to type these functions again. But since I had them in my brain, I kind of did a lot of copy and paste. So the next one, how far is this one going? Remember, it's 1, 3,
7.
5, 7. And the next one would be 9. I didn't do that one. Now, check this out. This is what I wanted to have you guys see, okay? So, A is 1. I'm going to make A 2. What do you think is going to happen to these steps? Are they yeah, they're stretching, right? Do you see that? So I'm going to make A5. How tall is the first step? How tall is the very first step?
5.
5. Look at it. If the number out here, A, right, like I set you guys up, is 5, the first step is 5. How tall is the next step? I'll even show you the numbers. It went from 15. And how do you get 15? 3 times 5. How tall is the next step? This got really big.
25.
Let's see what it is. 20. It is 25. And how do you get 25? 5 times.
I just add 10.
Oh, you add 10? Oh, that might work too, actually. All right. Let's see. It might. Let's see. Because you can add 10 from 5 to 20. Maybe. I think. Huh. Okay. I think I gotta see that. Let's see. So you added 10. It was 25. So what would be the next one?
So
30
35.
35. Let's see. I think you're right. Let's see. It went from 45 all the way to 80. It is actually cool. I learned something new today, you know? So you find the pattern and you go with it. So you add 10, which is 35. Now, the way I would have gotten 35, I would do 7 times 5, right? Because remember, the pattern is 1, 3, 5, 7. I would just multiply those numbers times 5, okay? All right, let me bring this back to 1 and then press home button. This is the generic quadratic, right? Each step gets bigger and bigger. Not like absolute value. They stay the same. Now, what if a is 0? Well, then we don't have a quadratic. It's a line. It's flat. Does that make sense? So a has to be a number, okay? All right, so a is going to be 1. Okay, let's move the parabola to the right 2. Which one do I have to change, the k or the h? I want to move it to the right 2. Which one do I have to move, the k or the h?
H.
H. And am I going to put +2 or -2?
Minus.
-2, because it's backwards inside. See that? Now it moved. Oh, I got to fix something. See my steps? It didn't follow the parabola. Oops. Oh, hold up. I know what happened. 1 second. 1 second. I changed the number up here. I'm actually supposed to change the number over here on the H. Does that make sense? So it still worked, but my formulas are all connected to the letters, okay? Now, what if I want to drop the parabola down by 3? Which one am I going to change? The A, the H, or the K?
K.
K, exactly. And am I going to put +3 or -3 on the K?
Minus.
-3. Remember, the vertical is normal, okay? So the K moves it up and down. The A stretches the steps up and down. K moves them. A stretches. H moves them side to side. K moves them up. So let's write that down on the notes and I'll come back to it. And by the way, do you think there's a way to stretch this parabola side to side? Yeah, we need another letter, but that's not for today, okay? So let me write that on the notes and then I'll have you guys do this assignment. And so let me just change colors. All right, quadratic. All right, f of x equals a x plus h squared plus k. All right, vertex. And by the way, the vertex is the same thing as the absolute value. What is the vertex? What's the vertex of this function? Pretend the letters are numbers, but so what is the vertex? And look at your notes from the right above the absolute value.
What is negative H?
Yes, negative h. And remember, you want to actually say opposite of h, right? Because if h was negative, then it would turn to positive, right? And then positive what? K. And steps. The first one is up 1 times a. What's the next one? Three times what? A. What's the next one?
5.
5 times a. And those will give you your points. Okay. And then you'll boom. And then the same on the other side, right? Same. All right. So let's try one together and then and then we'll do it. Okay. So let me have you guys open up your PACE, follow the Desmos activity, and I'm going to give you maybe 5 minutes or less to play around with or make sure to sign in with Google, because that's how I keep track of who did what. And play with that one the one page that I have. And this way I could take questions on. Right? Don't move on to the next questions because they're just blank. Okay. So remember, instead of changing the letters up here, change them down here. A, H, and K. There's only three numbers you really need. Okay. You could actually even move it like this, but I don't think that's as helpful. Okay. Now I did make
Question.
Yeah. Mm-hmm.
So it says, how do you find the x of vertex in standard form quadratic functions?
Oh, so I made a mistake on that. It should be, how do you find the vertex in vertex form? By the way, this is called vertex form, the way it looks here. Okay, so that's a typo. I got to fix that. So how do you find the, in this kind right here, how do you know what the vertex, the x of the vertex, right? So what is the x of the vertex on this function right here? We've been kind of saying that.
-3, 2.
Yeah, so the x of the vertex is just the opposite of h, right? Make sense? So let me remember, the vertex is two parts, the x and then the y, right? So let me go to my teacher one. So what I would type for that one is, I would say I would get the opposite of the number inside the parentheses. That's what I would write. Okay, let's see. But go ahead and play with that for a little bit here. Let me, and I'm going to reduce the number of graphs. Okay, so we're going to, okay. See, I can see who's logged in, all right? Okay, I can see what you guys would type. So go ahead and play with this. Look at the steps. Like I said, I spent a lot of time making this for you so you could visualize the steps, okay? And then you can make the steps become smaller by putting a 0.5 in A. Can everybody try that? Put 0.5 in A, okay? And I'll jump in on one of you guys. Let's see. Let's see, Hannah. See, I can see where you're at. So on A, type in 0.5, and then what happens to all those steps? What happens to those let's see if anybody else did that one. Nathan, did you put a 0.5 in that one? Yeah, see, there it is, right? So they got cut in half. Does that make sense? What if you want them really small? Can you guys put 0.1? They got really, really what? Small. What if you want them like really tiny, like a penny? They got really, really what? Small. What if you want them to go downstairs instead? Instead of going up, you want your stairs to go down. What would you change on A?
Make it negative.
Make it negative. And I would do a -1 just to see the original, right? Now, sorry that I didn't finish in order to do the steps on negative, I had to do like more math, more equations, but you get the idea, okay? And what if you wanted it to be like super stretched, like super tall steps, like steps that are so tall that it'd be impossible to climb them? How about 100? Look at that. So the first step is 100 feet, and the second step would be 300 feet, and then 500 feet. Okay. So most of the quadratics you're going to be using in our graphing is 1, 2, 3, -1, 2, 3. All right. All right. Do you guys think this is helpful? This what I spend time doing here?
Yes.
Yeah. And also you can move the H. Watch, if you move it to the right, the graph goes to the left. If you move H to the left, the graph goes to the right. It's backwards, right? But it's not backwards, but it looks backwards. K, you move it down, it goes down. You move it up, it moves up, okay?
I don't understand what we're trying to do.
You're on screen 1.
Yes.
Okay, you're exploring right now. You're exploring what A does. You know the numbers in the front of the quadratic, right?
Yeah.
You're exploring what K does, right? And you're exploring what H does. So you're trying to get it in your mind. So you're trying to wrap your mind around this very mathy looking, equation, right? You're like, what? There's just a bunch of letters, right? You're trying to wrap your mind around that these letters represent numbers, and if the number changes, it'll change the graph. But notice they're all parabolas. They're all U-shaped. No matter what you do to the letters, they're still going to be a U-shape. Okay. All right. So let's see. I'll give you a little quiz, Amar. What does K do?
K moves it down or up.
Down or up. And what does H do?
It moves it left and right.
Yep. Normal or backwards?
Backwards.
Backwards, exactly. And what does A do? The number that you would replace with A. What does that do? What does A do? And if you don't know, it changes what?
It takes it, it makes it bigger or
thinner? Yeah, it makes the steps, right? Make sense? Notice how the x's, which is 5, 6, they don't change. It's still 5 and 6. So who's only changing? The y or the x? Does that make sense? The y's are the only things that will change. So A will make these steps taller or shorter or upside down. Okay. All right. So let's get to the assignment. In the assignment, can you guys look at my screen real quick? Right here, there's problems that you're going to be graphing. Okay. And so you're going to graph these inside of the Desmos. And I'm only going to ask you to graph 5. Okay. So, and number 1 is this one. And what is the vertex of number 1?
Is that a positive one? That needs to be a positive one?
Yep, it would be a positive one. Oops. And then it would be, sorry about that. And what number is still out there? So if this is gone, what's still there?
2?
Negative 2. That would be the vertex. So what you want to do on the next screen, and I'll move you guys to, go ahead and answer, go to screen 2 and then answer that. And I will move you all to screen 2. Check this out. So answer that question. How do you know the x of the vertex? I would answer that by saying the opposite of what's inside the parentheses is the x of the vertex.
Can you repeat that?
Yeah, I would say, and I'll even type it in for one of you guys, okay? Let me just jump in here. Give me 1 second. I would say, let me just get out of here. How do I get out of here? Cancel. Okay. All right. I'm going to say, I would say, how do you find the x first? I would say this. I would say the opposite, this is an example, right, of -5 is 5. And that is the x of the vertex. So I give myself an example, right? And why is that the x of the vertex? Because 5 minus 5 would equal 0, and 0 squared, 0 times 0, is still what? 0. And that's the lowest point. Okay. Now the y of the vertex is 3 for my example. Because the 3 did not get affected by the 5 minus 5 squared. So 3 is still there. So instead of answering, I kind of just gave an example. And I think a lot of you would probably be helpful if you just make an example and you're like, okay, I know what it is.
So the example like we could put is kind of like that, or
Yeah.
we can just put how we got it. So
Yeah.
like we put the equation down
Exactly.
and we just put what it was.
Yeah, you could even say, you could do this. Ax plus h, right, squared, plus k. And I know the vertex is the opposite of h. Does that make sense? If you wanted to use like variables, right?
Yeah, that makes sense.
Yeah.
Okay, thank you.
Yeah. All right. So go ahead and finish that, and I'm going to. You can press share with class. We can see like different scenarios. Let me know if I can. Okay, go ahead and go to move to 1 when you're ready, and then you're going to just basically graph number 1 from the worksheet. Okay. I'm going to go out of Mars. Okay, so number 1. What was the vertex of number 1? It was 1, -1. So I would actually put that vertex at 1, -1, right there. Oh, was it 1 negative? Wait, hold on 1 second. I forgot what the equation was. 1, -2. So 1, -2. And I wish I could have written the equation. I think I can write the equation up here. Let me see how my screen works. Now, in the future, I'll have the equations written on the top. I ran out of time. Does that make sense, everybody? So I ran out of time in order. We had x. So what you could do, if you can, write the equation in the graph. -1 squared.
Wait, can you see what I'm doing?
I just kind of overwrote yours, but as you're working on it, I should be able to see what you're doing. Okay. And then from here, I'm going to go down 1 over 1, and then down 3 over 1, and then down 5 over 1. And is that enough to draw my parabola? Whoa. I went down. Is it supposed to be going down or supposed to be going up?
Supposed to be going up.
Up, because it's positive, right? All right, so it's going to go. Now, let's pretend I did that on purpose. I didn't, but let's pretend so I don't feel so embarrassed. Okay. That's going to be 1, and then it's going to be 1. Actually, I like to do rise over run, but it's going to be the same thing. Up 1 over 1, then up 3 over 1, and then up 5. 1, 2, 3, 4, 5. So what I want to see is you guys give me this, even though it's going to be a little messy, it's okay. And then you're going to do the graph. And 1, 2, 3. And then I wonder if you could zoom in. All right. So I want you to do 5 of these, and I'll stay with you and help you out as you're doing all these. All right, let me take a peek to see what you guys are up to. Okay.
So do we just draw them and that's it?
Yeah, look at this. All right, boom, you got it, right? So the first one was pretty easy because you have the steps and you have the vertex, and that's what you need, right? That's what I'm trying to get you guys. Like I'm trying to be like really astute about this. All right, Clyde, very good. Try the second one. And if you can you write the equation, even just the right part? All right, the second one is x plus 1 squared plus 2, so it's kind of almost the same thing, right? And all we're going to do is 5 of these, all right? So we're just getting the intro to it, okay? All right, good job. And Shiv, when you get it, when you're done, go ahead and connect your dots, right? Because you don't want to just have the dots, right? Good job. All right, here's Nathan's 1, 3, 5. Good. So try to put the steps as your. And oh, here's another good idea. You could put the table here, right? Very good. Okay. All right. Looks pretty good. Okay. The next one is, when you're done with this one, it's the same thing, but it's the other way. Oh, Olivia, be careful, because remember, quadratics, they're different, right? So they are actually the steps are different sizes, right? So the for number one, I'll do it here with you. What do you think the vertex is for number one? Whoa, what was that?
Would it be 1?
Yeah, 1 comma -2, correct?
-2.
There it is.
Yeah.
So put a dot right there, and you can put a little V, right, for vertex. Now remember, in quadratics, the steps are not the same size. They start off at a 1, and then they get taller, and then they get even taller than that. You basically, like Amar said, you just add 2, and then, so you want to have these 3 points, and I'm going to change color to red to graph the parabola, right? So the blue is basically just going to be my little guide, right? And then you got to make a mirror of it on this side. And then.
So that 3, what is the 3 going up by? I'm not understanding that.
It's okay. Watch this. Here, go ahead and look at my screen. Remember, on the very first screen, I'm going to change the A value to 1, because there's always a 1 out there somewhere if it's not there. So do you see my first step? How tall is it from here to here?
Is that 2 or 3?
Let's see. Yeah, let me make this. There we go. So how many squares is it from this square to this square? How many steps?
I think 1.
1, exactly. And then the next one, how tall is the next one?
3.
3. And then the next one is how far?
5.
5. Yep. 1, 3, 5. And what would you guess would be for the next one?
Probably 7.
7, exactly. So quadratics, the steps are never the same size.
Mm-hmm.
They get bigger and bigger. And now this one's 1, 3, 5, 7. And that's what I really want you to see. That's why I spent all this time making these little like steps. I wish Sophia was here, because she would actually draw a little stick figure here, right? Climbing up the way.
Climbing up the stairs.
And they're gonna get more and more tired, because the steps are. And then they're gonna be like literally trying to like climb this hill like a cliff, right? Barely hanging on.
Yeah.
I could totally imagine her drawing them, right? Because they're gonna get taller and taller.
100%.
Right?
Sophie, so 100%.
Oh yeah, and the first one's like easy. They'll have a big old smile. The next one they'll have like little like muscles, and the next one they'll be like hanging off the edge as they're pulling themselves up, right? And then the next one, she's gonna be looking up at the steps like, nah,
No, I'm okay. I'm
okay.
done. I'm down.
Or like with a rope.
Mr. Canuna,
Yeah.
can you check mine?
Yeah.
I feel like I'm doing this right.
What number are you doing? 2 or 1?
Number 1.
Number 1.
No, I'm doing
Okay. Yeah. So what you want to do next is connect the dots and use red and make a nice parabola, right? Because remember, your graph is not the steps. your graph is the parabola, right? The steps are your.
Yeah, it's kind of hard to do this.
Yeah, I know. It's okay. You just kind of. I'll try it with my finger. Just kind of like, you know, just make it. See.
Yeah.
I mean, I have the stylus, but I did this with my finger. Just the idea, right? And the reason I want this is because I can see what you guys are doing, right? Like instantly, right? All right. So go ahead and continue. Everybody else continue. All right. Good job, Sophia. This is the idea, right? Now you don't even need to literally draw your steps, like Sophia's here. You can just imagine the steps, and you don't really have to draw them. All right. You can just count it and go straight. So you can just count the steps, but you don't have to draw them. Okay. Like technically, they shouldn't be there, right? But they're there for your construction. All right. So that's one. So then let's see how many people are on number 2. Okay. Good job. Number 2, the graph shifted to the left. Okay. All right. Good job. Okay. And Claudia, how do you make it so smooth? Are you doing little lines or what?
I just press the line thing, yeah.
Oh, that's cool, right? So you go from one point to the other point, right? Yeah, I see that, right? That makes it a little cleaner. Okay, good job. Good job. All right, Hannah, good job. Yeah, right. If you guys can do me that favor, is write the function because you're going to be able to see. On the next time we do this, I'll have the equation on the top. Okay, I promise. I just like I said, I run out of time today. I would have written it up here, number 2. Okay. All right, a couple of you are number 3. Good job. All right, and I'm curious about number 3. Somebody's is going up and somebody's going down. Let's see. All right, Claudia, why is yours going down? Is there a reason for that?
I don't know. I just went -2, so I just
Careful. Remember, your steps are in the A. The -2 doesn't tell you the size of the steps. The size of the steps is over here in front, which happens to be what? Does that make sense? 1.
Yeah.
Okay. So
I was confused by that because it doesn't have anything.
Exactly. So when it doesn't have anything, it's a normal 1, 3, 5, 7. Right?
Okay.
And most of the ones you guys will get won't have anything. And you're like, cool, that's even easier. 1, 3, 5, 7, right?
So I have a question.
Mhm.
For number 2, does it increase by 2 every time, or?
Let's see. Number 2. Yeah, I think that's the normal 1, 3, 5, 7, right? Let's see. Let me figure out how to get out of this thing. There we go. So number 2. All right. Yeah, so number 2, it's the same as number 1. Right? It's still the 1, 3, 5, 7. Now the A value, like I was telling Claudia, is not. It's a 1, so that means it's the normal 1, 3, 5, 7 steps. Okay. So if there's no number here, it's a 1, which means the steps are 1, 3, 5, 7, and like you said, you're adding 2 basically to the previous one. Okay. That's one way to look at it. All right, Nathan's on that one. Claudia fixed hers. Okay. Kennedy's got that one. So this one, the number 3 went to the left and down. Perfect. Okay. How do you determine if the parabola goes up or down? Good question, Hayden. The A value, Hayden, can you look at my graph here? If you change the number in front of here, like this A value, if you put a negative there, it'll go down. So if the number in front of the parentheses is negative, the steps are going down instead of up. Okay. It doesn't matter what H and K are. What matters is the negative in the front. Okay. Good question. All right, let's see. All right, so, and some of you are on 5, and when you're on 5, just all you got to do is say thank you and have a good weekend. And remember, tomorrow I'm not going to put any assignment, just to give other people time to catch up. And if you can text your peers, let them know that I'm giving them time, to catch up. And even if they didn't catch up next week, and it's just that we don't want to have like somebody coming, oh man, I have to watch 10 videos and each one's an hour long. Like, yeah, we've done it, right? Every day, an hour. All right, let's see. Cool. And like I said, just the 5 is good for now. And then on Monday, we'll pick it up. Okay. All right, so let's look at the equations. What do they get more complicated, or they're all pretty much simple stuff? Let's see. Dang it. So the only one that changed was number 5, and I should have looked at this better. I should have had you guys jump around, right?
Are we doing to number 5 on the worksheet, or to number
Yeah.
5?
Yeah, you're just going to do to number 5 from the worksheet in the Desmos, and then we'll pick this back up on Monday. So number 5 is the only one that doubled the steps, right? You guys agree with that? All of the others, they were the 1, 3, 5, 7. Okay. But number 5 doubled the steps, and then we'll stop there, and we'll continue this next week. Okay. Number 10 made the steps half and negative. Kind of weird stuff, but it's okay. So when you guys are done with the 5, if you don't have any more questions, you're going to be done with that. All you're going to have to do is post your notes, and then I'll get your screenshots of this, so you don't have to take pictures, because I can see what everybody does. So when I do the grades, I basically log in here and I see who did all of the problems, basically to screen 7. Right? All right. Let's see. While you guys are finishing that up, I'm going to make
So for number 5,
Uh-huh.
when it has that 2 in front of the parentheses, do I just multiply that by 1 and 3 and 5?
Yes. Yep. And you're basically another way to think about it is you're going to double 1, 3, 5. The steps are going to be double of what they used to be. Right?
Okay.
If you think of it that way, it's a little easier, but you can just multiply it by 2, but you feel like, oh, they're going to be double, right? Which is going to be 2, and then 3 times 2, 6. I think you're basically going to just add 4 to that. Instead of adding 2 like before, you can add what? 4. So it's gonna the parabola is gonna look skinnier, but it's not skinnier. It's taller. Right? It's stretched. And let's see here.
So when we're done with 5, we're just done for the day?
Yeah, done for today, because I want this to be a really gradual process. Does that make sense? Right? So that's your brain is absorbing a little bit at a time. Okay. So remember, today's lesson was that the A value determines the height of the steps, right? In the absolute value, they are the height of the steps. They're all the same as whatever A is. On quadratics, they actually multiply 1, 3, 5, 7. They multiply those steps. Finding the vertex is the same thing on absolute value and in quadratics, and that's why I kind of combined both of them. And then like I said, this is actually really helpful to visualize the steps. Okay? So I did put the assignment on number 9 for notes if you want to just get that over with, so you can go about your day, have lunch, and I'll wait here for everybody else. Okay, if you have any more questions.
Do we have a class tomorrow?
Let's take a day off tomorrow. Is that okay with you? Yeah. Let's take a day off to let people catch up, and then we'll meet up on Monday. Okay. And I think
All right, bye, Mr. Quinones.
Bye. Have a good weekend.
You know,
You're welcome. Bye.